The Earth 2.3 billion years ago was in the Huronian glaciation period. It is the second known ice age. The first known one happened 2.9 billion years ago, which is the Pongola Ice Age. However, this one is not as well established as the Huronian glaciation period. After the Huronian, there is a pretty big gap in ice ages. So for somewhat more than a billion years, the Earth was in a greenhouse period and it lacked the polar ice caps. Then from 720 million years ago to the current time point, 4 different ice ages were recorded. Currently, the Earth is in the Cenozoic Ice Age, which started 34 million years ago with the formation of Antarctic ice sheets. And it is only 2.6 million years ago that the Greenland ice sheet fully formed. However, the current ice age is rather mild compared to the Huronian ice age. Looking at Earth during the interglacial periods of the Huronian would typically reveal a planet that was already resembling current Earth by quite a lot. The atmosphere was blue. The orange haze from the methane was gone by this point. The ocean was also blue. Its dark green color was at this point lost because the iron wasn't dissolved anymore. One study says that the Earth went through 3 different glaciation periods between 2.29 and 2.25 billion years ago. So within a time span of 40 million years, at least one of them, if not all 3, were quite possibly snowball Earth events where the entirety of Earth's surface was covered in ice. The evidence for this event is found all over the planet in the form of glaciogenic rocks, indicating that the glaciers were present at very low latitudes near or even exactly at the equator. However, some studies disagree with the interpretation that the Earth was a snowball, as in covered in ice, even down to low latitudes. Rather, the proposals are that it was either a slush ball, so there was plenty of slush at low latitudes, or that the glaciers are evidence of local events. Still, what there is entirely agreement on is that the glaciers were abundant during this time. As far as what the Earth potentially looked like, at least mid-latitude glaciers are very likely, either as a transitional stage to a fully ice-covered Earth, or to a stage where there is a bunch of slush at lower latitudes. The Huronian is the time point during which one of the earliest supercontinents started breaking up. Kenorland potentially formed around 2.7 billion years ago, and then by around 2.3 billion years ago is when it was on its way towards being significantly broken up. The scattered land surface area was covered with ice all over the planet. Even if there was open liquid water in the oceans at the equator, when it comes to land, even if exactly at the equator, it was very likely covered by glaciers. Land has a much greater capacity to hold ice than water. Although there is some evidence that there were mountain building processes occurring during the Huronian, such events and their scale are not fully confirmed. What is likely, however, is that there weren't as many mountains as there are today, and they probably weren't as tall. So the landscape was typically probably flatter than it is today. However, there were still mountains, of course, and they very likely had very sharp peaks because there wasn't any vegetation back then to soften the terrain. The Huronian consists of likely at least 3 different glacial periods, so there were likely at least 2 interglacial periods where the temperatures were high and there was high humidity. Considering the huge portions of land ice started melting during those periods. That also led to algal blooms, as the nutrients carried from land glaciers caused for the cyanobacteria to replicate very fast. During the interglacial periods of the Huronian, likely massive portion of the ocean near the coastline were green. Algal blooms were way more common. Scooping up a sample of water near the coastline would reveal a very green, murky water. Although the individual organisms were invisible in large enough quantities, they changed the color of the water. Cyanobacteria were completely taking over the Earth and were actively transforming it. Although they were somewhat different from the ones currently present, by that point they evolved the ability to synthesize oxygen. The Huronian glaciation happened right in the midst of the Great Oxidation event, where the cyanobacteria started pumping out so much oxygen into the atmosphere it caused for oxygen to react with atmospheric methane, which led to methane being taken out of the atmosphere. Since methane is a potent greenhouse gas, it being taken out of the atmosphere caused for the temperatures to drop, which allowed for the Huronian glaciation to take place. Beyond oxygen taking out methane, it also took out the dissolved iron out of the ocean. So oxygen reacted with the iron dissolved in the ocean. That then caused for the iron to sink to the bottom, which then also cleared up the ocean of its dark green color. However, the cyanobacteria themselves are green, so huge parts of the ocean, specifically near the coastline, were very green. But further out from the coastline, there were far less nutrients, so the cyanobacteria weren't nearly as prevalent, and therefore the huge parts of the ocean had a dark blue color. Today, algal blooms still happen in ponds, lakes, and oceans. They can occur naturally or due to human activity. They happen when there is a sudden influx of nutrients in a body of water. During the interglacial periods of the Huronian, however, these blooms were much more intense, potentially capable of stretching for hundreds of kilometers away from coastal areas. The humid environment during the interglacials potentially made it such that there was plenty of cloud cover and with that rain over continental areas. This then likely formed many ponds and lakes. The retreating glaciers during the interglacials also very likely produced countless lakes. The Canadian Shield today contains some of the oldest rocks on Earth, some going back to even 4 billion years old. The Canadian Shield is exactly one of those places where evidence for the Huronian glaciation was found. Today the landscape is filled with countless lakes. Canada has more lakes than the rest of the world combined. This is due to the fact that it was recently under a glacier. When it retreated, it left countless small rocky basins to be filled with water. The reason the Canadian Shield has so much exposed bedrock, and with that rocky basins, is because the retreating glacier scraped the landscape of large chunks of its soil, and the low porosity and permeability rock that survived for billions of years also made it such that water ponds very easily. Since the Canadian Shield even existed during the Huronian, it is very possible that it had countless lakes back during the interglacial period. However, the shield certainly did not look like it does today. That ancient continental area went through many significant changes. At one point, it hosted mountains that were possibly even taller than the tallest ones today. So, how exactly did it look like during the Huronian is hard to say. On land, there was no organic dirt, or rather organic soil. That came way later with plants and animals. The land was instead almost entirely a mix of fresh basalt, so freshly solidified lava, and also heavily weathered rock that was by that point hundreds of millions of years old. That old gray rock contrasted heavily to the dark fresh basaltic rock. Besides that, there were also huge red areas that were the size of countries, and they also had sandy ground. The reason these red areas formed is because of the oxygen pumped into the atmosphere by cyanobacteria. That oxygen also reacted with the minerals on the surface, causing them to turn red. The huge areas with red sand also potentially were at times producing red dust storms when the conditions were right. It is important to note, however, that the Great Oxidation Event, or the Great Oxygenation Event, only managed to reach the atmospheric level of oxygen that is 1 to 2%, which is a massive rise in oxygen compared to the previous periods, enough to transform the planet, but that level of oxygen pales in comparison to the level which is currently present, which is about 20% of the atmosphere. Although methane was taken out of the atmosphere during the Huronian, CO2 was abundantly present, approximately up to 10 times greater than the current levels, maybe even more. During the interglacial periods, with high humidity and high temperatures, this then led to intense weathering of rock materials. Specifically, the rain itself was likely more acidic because the abundant CO2 in the atmosphere, once dissolved in water, also creates carbonic acid. The acidic rain then leached the minerals from the rocks on land and drove them into the oceans, which also helped create algal blooms. During the snowball or slushball Earth states, there was next to no rain because the temperatures dropped down to below 0 degrees Celsius. There were times during which it snowed, but it also wasn't snowing that frequently either. During these icehouse periods, total precipitation was overall lower. One explanation as to why Earth had these icehouse and then warm and humid interglacial periods is due to the effect of CO2, which during the icehouse periods was accumulating in the atmosphere because the volcanic sources were still pumping it into the atmosphere. It wasn't able to be taken out of the atmosphere because of the huge amounts of ice at the surface, which didn't allow CO2 to interact with silicate rocks, which take CO2 out of the atmosphere. This buildup of CO2 during the icehouse periods caused for Earth to enter into the warm and humid periods. Then the at the time relatively recent breakup of the supercontinent Kennerland led to plenty of silicate rocks being exposed, which took out the CO2, and that then led back to the icehouse periods. Although the surface area of Earth was likely covered in ice, especially the land areas, there were still likely relatively small land areas that were entirely ice-free. Even today in Antarctica there is a region called McMurdo Valleys near the coastline which is snow-free. It has a surface area of about 4,500 kilometers square. This region is potentially the closest to what the Earth looked like during the Huronian. During the Huronian, including the interglacials, the only organisms which were present were single-celled ones that are microscopic. But the ones taking over Earth during that time were quite a bit different from the previous ones. The existence of cyanobacteria, which pumped oxygen into the atmosphere, also led to the mass extinction or reduction of some other organisms. Crucial microorganisms that likely underwent a serious reduction were based on retinol instead of chlorophyll. This then made them purple in large enough quantities. Because of their potential abundance, this then also potentially made Earth have a purple hue in coastal regions, or maybe even the entire atmosphere. That purple hue disappeared as they also largely disappeared. Today, these ancient organisms still exist and sometimes bloom in very extreme conditions, such as very salty lakes, but they are certainly not dominating the planet. This also means that it's hard to say if the Earth had green or purplish oceans before the Great Oxidation event, but it could be a combination of both, as in purplish in the coastal regions, but dark green further away. During the interglacials, there were microbial mats in moist and likely many coastal regions. They formed a thin surface layer that colored the surface. They also overlapped with the red land areas mentioned earlier. Some interesting microorganisms that were present on land during the interglacials are chemolithotrophs, which can get their energy from inorganic, non-carbon-based compounds. They were surviving off of fresh volcanic rocks, in a way consuming their iron and sulfur. In water, the microscopic life was most abundant in top 200 meters where there is some sunlight. However, there were still microorganisms in deeper parts of the ocean floor, particularly so around hydrothermal vents, which gave plenty of heat and nutrients. Speaking of the ocean floor, it was also likely very different. Although it very likely did have trenches, they were not as deep. There were likely plenty of red, iron-rich sediments that were frequently more than 10 meters thick. The interglacial periods also experienced times when the melted ice that originated from land carried the rocks from land and made them drop onto the ocean floor once the glaciers melted in the ocean water. These are called dropstones. These settled into the sediment of the ocean floor. The sediment itself was also different. Because there were no organisms to mix it up, different layers of material formed. The floors also had growing crystal structures that were up to 1 meter tall. A day on Earth during the Huronian was only about 17 hours long, which means that on the equator, daytime and nighttime lasted about 8.5 hours. The moon was also a bit closer during this time, about 330,000 kilometers away from Earth on average. Today, it is about 380,000 kilometers away on average. So that is what the Earth was like 2.3 billion years ago. It was going through the icehouse periods with warm and humid interglacials, and it was starting to look more and more like the Earth we know today, especially color-wise. But of course, there were still no animals back then. The landscapes were largely barren, and the atmosphere, even with quite a bit of oxygen, was still unbreathable for humans.